we look at the function y equals 2 times the quantity x minus 4 squared minus 3. And we recognize immediately, if we understand what we need to know about transformations, that there's a vertical stretch by factor 2, a horizontal shift of 4 units, a vertical shift of negative 3 units. We construct the graph of this function step by step using the transformations. So that the first transformation we do, remember we have to do stretches, and if there are compressions, we do compressions as well, before we do any shifts. So the first thing we do is we vertically stretch by factor 4 so that the y equals x squared function, which is the yellow graph here, and you can sketch your own if you wish, and it's a good idea if you do, the y equals x squared graph becomes then, or is transformed to the y equals 2x squared graph by doubling all the y values. Obviously, if you go from x squared to 2x squared, that doubles your y value. Doubling the y value moves every point twice as far from the origin. So we take every point on this yellow graph, move it twice as far from the origin, so that a graph with a y point with a y coordinate of 1 will have a y coordinate of 2 for the same x coordinate, and so forth, and we get the green graph. Okay, so we've doubled all the y values. Now we've got tables over here. We'll talk about those in a minute, but it's pretty obvious how that works. Then we take the y equals 2x squared graph and we shift every point 4 units to the right because our horizontal shift is 4 units. And our 2x squared graph then transforms into the 2 times the quantity x minus 4 squared graph, the purple graph you see here. And you see these arrows going from points of the green graph, the 2x squared graph, okay, over to the purple graph. Every point of the green graph transforms by moving it 4 units horizontally to a point of the purple graph. And in particular, your vertex, which stays the same for the vertical stretch, shifts over 4 units to give you a vertex at 4, 0. And that's important. You want to kind of notice that. Okay? But shifting every point 4 units to the right gives us the purple graph, and then we have a vertical shift of negative 3, meaning we take every point of the purple graph and shift it down 3 units, and we end up then with the graph of our y equals 2 times quantity x minus 4 squared minus 3 graph. Okay, now we're going to look at intercepts and so forth, but we're going to, in a subsequent video, just look again, we've already looked at it, but look at what happens to the tables of our values for the functions.